A is playing the role of 4m, and B is playing the role of 3. So you wind up with 4m plus 3, 16m squared plus, minus 12m plus 9. And I know yesterday a couple of you guys had asked me if you could factor out that last chunk. It's not going to be factorable. Yes?
You told me yesterday that A equals 8x.
I did the square root, that's why.
Yeah, you said
Sorry! I meant 4!
Well, you need to get your stuff together, sir.
I'm old.
Yeah, I know. Just taught these kids are
That's how it works. Yes?
That's it.
If it says like M cubed, can you write
I try to make sure it would just all X's when I
Wait,
type
can
out
you do
tests.
12?
When I use software, it just spits out variables. It drives me nuts.
Is that the answer?
Yeah, you're done. That's all you can do. Oh, forgot to put the 2 out the front.
16.
Oh gosh, okay.
Which one? 16?
Oh, no.
Can't you group 16?
No,
Bro.
I had to do one.
I don't know. What, 16? 16? Yeah, 16 you can group.
Nice.
15.
I'll get the 15.
What? How do you know when to group and when not to?
When there's 4 terms, I group.
When there's 4 terms, it's always a good idea to see if you can group, because usually you can't. So try and group when you see 4, see what happens. Take out the x to the 4th, we get x squared plus 5. Take out the negative 4, we get x squared plus 5. So you have x to the 4th minus 4, and x squared plus 5. I can't factor that any further, but here I can go x squared plus 2, x squared minus 2, and I have x squared plus 5. I believe that this one said factor, or did it say find zeros?
Factor.
It says factor, but
Yeah, and then if it said find all zeros, you'd have zeros at plus or minus square root of 2. And then you'd have plus or minus I root 2 and plus or minus I root 5.
Okay.
Okay. Because of the way that
That's not
How'd you get x squared plus 2 and x squared minus
is x to the 4th a perfect square?
2?
Is 4 a perfect square? Is that a subtraction sign?
It is a subtraction.
So that's a difference of squares.
Okay.
What if it was addition?
What's that?
What if it was addition?
It doesn't work that way.
So
If you guys
That's
did-
it?
And then, yeah, because if it was x squared plus 4, you go, is this a perfect square? You say yes. Is this a perfect square? Yes. Is that a subtraction symbol? No.
so then it'd be just x to the 4th.
So that'd be it. So that would be it if it was like if it was addition.
Yeah, because then you'd have to do other stuff.
so in other words, it's two perfect squares.
Yeah. What do you got?
You only need an I when you're hearing the square root of a constant, right? So like
No, we take square root of a negative.
Well, like the positive changes to a negative is what he's
Yeah, oh yeah, because you have to subtract the 2 to take the root. Yeah. Oh, did you need to see 15 still? I'm sorry. Did you guys still need 15?
It's like the same thing.
Okay. What was it, 21 you said? I remember they had said 15 earlier and I didn't want to skip over them. As much as I'd like to.
I hate these.
I love these. These are fun. If you have one, you're going to have the other, so you're going to have 4 terms here. So when all's said and done, you should have a 4th degree polynomial. You're going to have x minus the 3 plus 3i. You're going to have an x minus 3 minus the 3i. You'll have an x minus the negative 2 plus I. And an x minus the negative 2 minus I. All I'm doing there is just setting it up as far as subtracting out 0 each time. The next step would be to go ahead and redistribute that negative. So you're going to see your little your chunks that'll work out a little bit cleaner. You're going to get x minus 3 minus 3i. X minus 3 plus 3i. X plus 2 minus I. X plus 2 plus I. Just got lost where I was at. Each of those two individual parts wind up being differences squares. So it's going to be first term squared, subtract second term squared. So you're going to wind up with x minus 3 quantity squared minus the quantity 3I squared. Same thing on the other side. It's going to be the quantity x plus 2 squared minus I squared. I didn't have to worry about throwing the I in parentheses because there's no coefficient except for 1, so it's not going to be so bad. When we get to this point now, I'm going to do the 3I squared first, 3I quantity squared. That gives me negative 9. So this winds up being plus 9. This winds up being plus 1. So now I'm left with x squared minus 6x plus 9, x squared plus 4x plus 4 plus 1. The two trinomials you'll have to multiply out will be x squared minus 6x plus 18 and x squared plus 4x plus 5. You just have to multiply those two out, distributing, and they combine like terms.
Wait, how do you get 6x? Like, I know you gotta distribute the.
X minus, when you FOIL that out, you're going to get negative 3x,
okay.
negative 3x, and then you get the plus 9.
Yeah.
Really, like that?
Forgot you had to FOIL that.
Yeah. What happens a lot of times when you have junk squared, that pattern, and that's what I was doing earlier, where it's first term squared, last term squared, and then it's going to be minus or plus, depending on what the sign is, double the two put together. And that's kind of like a little fast pattern for that. Yeah. Whatever that works out to be, x to the 4th times a whole bunch of other stuff.
It's something like that.
It's something, whatever.
And that's your answer?
Well, you have to FOIL it out completely.
Yeah, that's your answer then.
Yeah, whatever that winds up being. Do you need me to write that out?
Wait, so that, you have to FOIL that out again?
Yeah, please do write it out. So it'll be a lot easier.
Send it over. We have x to the 4th minus 4x cubed plus 5x squared minus 6x cubed minus 24x squared minus 30x plus 18x squared plus 3672 x plus 90.
Why is it negative 4x?
What's up?
Yeah, should it be for?
Can't that do that?
Okay, I get what you're saying.
There you go.
I said it, I thought.
No, that's okay. Good try.
And now it's a matter of adding. So x to the 4th, cross it out, plus 4x cubed minus 6x cubed, so it's minus 2, plus 5 minus 24 plus 18, so that's plus 23 minus 1. Uh, 42 and a 90. I wonder if I was right. I hope so.
I hope so.
What number was that?
21.
Oh, you know why the answers are in here? I forget who was asking about that yesterday. The question stated, what are the missing terms? So the missing terms were the 3 minus 3i and the negative 2 minus I. I just make you multiply it all out, though. That's all. So that's why.
That's what I was like.
What's that?
We have to find,
No, you gotta multiply that out.
we have to find the zeros, right?
Yeah.
That's all.
Wait,
Wait, I got a question.
Find all additional.
find all additional zeros, is that just that?
Yeah, it's just what are the two missing zeros would have been. But I'm asking you guys to multiply it all out then. That's all. I'm asking you to write out the whole column. That's what I would do.
So if you still did zeros, the other problem like that,
No,
you do all.
That's what you had already done. Which one? No, I can't see what number that is.
Oh, sorry.
18? Yeah. All right, let's look at 18.
There's some more I have, but they're mostly.
Mr. Murphy,
Yeah,
I have a question on the quiz. Like, maybe fifth.
yeah, let me do 18 real quick and then I'll do that, all right?
Okay.
Anytime you see 3-term, guys, anytime you see a 3-term polynomial and your degrees are going down in half, Always try to factor it like you would a regular old boring quadratic. What times what's positive 25 you add together to get negative 26? Negative 25, negative 1. So you get x to the 4th minus 25, x to the 4th minus 1.
You can do that.
Yeah, we've done it a bunch of times. So now, because if you FOILed that out, what's x to the 4th times x to the 4th? X to the 8th. Now, is x to the 4th a perfect square?
Yes.
Yeah.
Is 25 a perfect square?
Yeah, it is.
Is that a subtraction symbol?
Yes.
Yay! X squared minus 5. X squared plus 5. Is that a perfect square? Is 1 a perfect square? Is that a subtraction symbol?
Yes.
You get x squared minus 1. X squared plus 1. Are there anything written out there that I can factor out further?
No.
Or did it ask to find zeros on this one?
It
just said factor.
just factor.
All right, so if it said factor, am I done?
No.
No, what else can I do?
X squared minus 1.
This guy. I can still factor this one a little bit further, and I'd get x minus 1, x plus 1. The rest of it I can't factor any further, but let's say I asked you to find all the zeros. I'd have to have a total of 8 possible zeros, so I'd have plus minus root 5, plus minus I root 5, plus minus 1, and plus minus I. Well, there's a whole lot of imaginary roots there. 6 of them. Exciting. Nice.
Wait, why is...
Somebody in here didn't write their name on something. I'm sending it
It's
back.
not-
What's up?
if it's the x plus 1, how come it's plus minus 1? Wouldn't you just be minus 1?
See how this was plus 1 and then it was minus 1, so I just wrote plus minus. Instead of writing positive and negative. I've always seen enough math videos. I got more math videos when we get into logarithms and stuff. I got some really cool stuff to show you guys. It's fun. Cole, what was the question? You said you had something on a quiz?
Well, I'll just ask you like.
No, I can just do it. Do you remember which one it was?
It was.
All below is fine.
It was 13. Like it said factor out, and I factored it out, but then you put an equal sign.
Oh, you might not have gone further.
Okay.
That's 13.
So I didn't know. All it said was factor, so I didn't know how far. Okay. Oh, I got it.
I hate how slow this thing is. Come on. Oh, you got to this one?
Yeah.
I think I know what you're talking about. A lot of people stop. What happens here on this?
You have the x squared minus 1 then.
Yeah,
Yeah. That's okay.
because I think it's because that one said factor.
Yeah.
So for this one here, it's the same basic idea. See how you've got 3 terms? Your degrees are getting cut in half each time you go 4, 2, then nothing. Well, what would be the first rule of factoring?
GCF.
What's GCF? 5. So the 5 comes out, and you're left with x to the 4th plus 2x squared minus 3. So what times what's negative 3? Add together to get positive 2.
Negative 1 and 3.
So you get x squared minus 1 and x squared plus 3. Of that, you can do it a little bit further. That would be the fully factored form.
All right.
That's a lot of F's. Fully factored
I did
form.
not write that.
For Friday. Fun.
Wait, so 13? Yeah. On the quiz.
Freedom Friday on a Wednesday. You haven't seen Lego Movie?
It's a pretty good movie.
I love that. It's really it was funny. My father-in-law watches our boys a couple of days a week, and the other day we had tacos and it was Tuesday, so the kids like, hey, it's Taco Tuesday. Let's watch the Lego Movie. Cool, let's put Lego Movie in. So we're watching Lego Movie, and Grandpa had never seen Lego Movie before, and he sat there with this big smile on his face throughout the whole thing. He was actually laughing and chuckling. He's like, and he got done. He's like, I really enjoyed that movie. You know, so it's funny. What are you gonna say, Edgar? What do you got?
Number 8 on the quiz.
Number 8.
Yeah. I didn't what it doesn't have is when it's just like an X,
Uh huh.
how do you
Well, first of all, what do you have to do about a polynomial?
Make sure it's in descending order.
Make sure it's in descending order. Shoot! Exactly. Negative 4x to the 6 plus 3x plus 8, which means your descending order, your tails are down, down.
Down, down.
Yep. You have to put them into the order for the rules of polynomials to work. Yeah, that Murphy, he's a trickster. Yes, sir.
Can we do 23 on the worksheet?
Sure. Find all the zeros. So I have a fifth degree polynomial, which means I should have possibly 5 zeros. In this case here, you will notice that you have 4 terms. I can group, but first thing I'm going to do here, well, oh yeah, we can group. If I group it, I'll get my GCF that way. Take out the x to the 4th, I get x plus 5. Take out the, what is it, 3x squared. And I still get an x plus 5. So what happens now is you get x to the 4th plus 3x squared and an x plus 5. Here, what could you do? Take out the x squared, and that's where you get that multiplicity 0 here. So originally, if you took your GCF out right away, you would have gotten that x squared out, and then you could still group and you would have wound up with the same solution. Okay? So your zeros here we're going to be at 0, plus minus I root 3, and negative 5. 0 just has multiplicity of 2. No, it's okay. Are the powers going down in half?
Yeah, Mr.
We
Murphy.
did the same thing.
Mr. Murphy.
Mr. Murphy,
You said that you don't have
you
to
said
write
it doesn't matter, but you marked it off on your quiz.
What
You marked it off writing the 0 twice on our quizzes.
did it say about multiplicity maybe?
Find the real number zeros and graph the function via the tail behavior.
Oh, that just means you didn't do something else wrong.
I wrote 0, I was multiplicity out.
Oh, because this one here, you have to, if it has multiplicity, it's going to go through the graph twice. That's the idea. Because if you're graphing it, if it had multiplicity with the graph, it would touch it and change direction. That's why you have to have that. When you're doing graphing, that's when you have to make sure you show that it goes through.
Put a smiley face on mine, saying it has multiplicity.
Not many people did that, so I was like, hey, look at that! Somebody remembered what the word was. You might even spelled it correctly. You never know.
I'm pretty sure I did.
You can probably think of it.
What times what's 14? You add together to get 9. Negative 9.
Negative 2.
And go to the next problem.
Wait,
That's what I have. I do the long way when it comes to this. Like, I do like x4 minus 7x squared or something.
It works.
It works.
Yes, ma'am.
Nothing can be multiplied twice to get to 1 times 1 multiplied by itself.
What number are you looking at?
Are you taking this home? Yeah, okay, because I'm probably gonna ask you questions.
Yeah, you'd have, this would be, there'd be a negative 3i, there'd be a positive 3i. So that means the term would have been x squared plus 9.
It's only those ones that are like, so you don't need a minus sign, or do you?
No. You have to worry about the opposites when there's an I or a radical.
Okay.
That's the only other time you have to worry about it. Yes, ma'am.
just so I can.
Getting lucky today.
I know.
This is my lucky day, guys. So,
Other than personal life, but
it's gonna go up like
Okay. So here we have to, I can't group it, it's not going to get me anywhere. So I have to do my synthetic, I'm going to try and do my synthetic division.
This is gonna be up, right?
This one should be up, yes. I got to throw that 0 in there for the 3rd degree. So I have, we'll try it at 1, 1, 1, 1, 1, negative 1, negative 1, 0, 0, negative 1, no.
These are like the word show. The song. Oh yeah. What's that?
Try negative
2.5.
1.
2.5, so it's gotta have, it's gotta work.
Yeah, it doesn't
I
work.
don't think it works.
This is a.
That is awkward, which means you have to use your calculator.
No.
What if we don't get our calculator? We can't use it. I know.
Well, if I have you graph something without a calculator, that means it's going to work without a calculator.
I would, what if you gave us this one?
Oh, I should show you guys this.
My head hurts.
The graph dances.
I won't cry.
We got the we're gonna do sine graphs,
Oh,
cosine graphs, tangent graphs,
I don't like
cotangents, absolute values.
I'm not. You're
The
gonna
last one?
The last one is crap.
Nice.
You gotta throw a leg kick in there. That's what makes things
Did
cool.
you make this?
No.
He's not that good of a drawer.
I forgot the function already. It was x to the fourth.
Minus 2.
Ah!
Carry.
X to the fourth.
Minus 2x
Oh, I feel you, man.
plus x minus 4.
It's a W.
Minus 2x squared.
What's that?
Squared plus.
I did. I
Plus
did.
X.
It's still. What happens here is you'll notice if you look at the graph, it's going in between. The way that our rational root theorem told us is that we have all the factors of 1 divided by all the factors of 1. So there's really only 2 regular integer value numbers that we could try, which just means that all the other roots aren't going to be rational. They're going to be fractions. They're going to be radical answers or something like that. That rational root theorem isn't going to find you those square roots. They're not going to find you the imaginaries. So what happens then, in this case, you'd have to go and approximate your zeros by calculate 0. You can approximate your relative minimums, where you change direction here at that relative maximum. So you've got 2 relative minimums and a relative maximum. It's all straight calculator. You are not going to be able to get zeros via synthetic on this case. So that means that if I have you graph something and ask you to do all of that, all you're doing, really, is pressing buttons. If synthetic isn't going to get you a 0. Yes, ma'am?
If I see the maximum number of turns, would that be 3?
Correct. It's a 4th degree polynomial, which means it can have the maximum number of terms it can have would be 3. Remember, it doesn't necessarily have to have all 3 of them, because we do have 4th degree polynomials that have imaginary roots which won't show. For example, if we go back and look at, which one was it? This one. This was an 8th degree polynomial, which meant we could have up to 7 possible changes in direction. What you'll notice here is if you looked at this in a graph, it's kind of cool. X to the 8th, I already forgot it, minus 26. Plus 25. You're getting 4 zeros, but only 2 of them are going to be numbers that are calculatable. Excuse me. What's up?
On my graph, like part of it is showing.
Change your window.
No, like it's not. She typed it the same, but it's not looking like.
The one we just did?
Yeah.
Because you have, it's not a minus sign, that's you multiply times negative 1. That's, it uses a subtraction symbol, that's why. Guys, subtraction symbol is not the same as the negative button. They don't work the same.
I never can too.
It happens. It happens. Okay?
How do you know? Can you go back? Oh, wait.
Yeah, what happens is, when we're talking about this relative minimum thing, remember guys, the relative minimum in this curve,
I think this one would be just.
there's 2 separate minimum values. The reason they call it a relative minimum is because it's within a specific parameter. So it occurs within two different spots. That's all. You've heard you read out both of them. You've heard the term "it's all relative."
Yeah.
It's kind of it's all, and that just basically stems from it's all dependent upon what you're looking for. I'm trying to see if you can find the graph. Sure.
What is the answer?
What else want to look at?
Wait. So then we just do second trace. And then
No trace. Second calculate.
Well, it's second trace.
Oh yeah. Sorry.
And then you just find the.
All right, let's make sure you're not using the trace function. Yes.
You find the minimum of both of them.
Yep.
And then the max.
You just do them one at a time.
Okay.
Because it won't find multiple minimums within a set of domains.
You feel like it. You got Chelsea.
Exciting. You don't look very excited. Why? Why? Shoot. Why? I feel better today, as you can tell.
0.26.
You don't care. I didn't feel good yesterday. I feel better today.
That's good.
Bless you.
So kind of round.
It's good conversations. A couple other things I would suggest if you guys are perusing through. What I did here is I have on the website the chapter 6 review, which basically is the review from the book, and it kind of goes through section by section, a bunch of different problems, different things to check. Doesn't hurt to go through them. The odds are in the back. You can always double check your answer, see if you got it right. Obviously, we did not do this whole third order differences and things like that. We did write the cubic function. We will do these third order, bless you, we'll do those difference things second semester. It's actually kind of cool. And then there's like little test parts, you can try some problems there. Also on there I have the extra practice problems for the back of the book, which is another tab of all the problems from the, in the very back of the book they have all those extra problems for all the chapters.
Oh yeah.
Is there an answer key?
I don't think so for this one. But you can scroll through and you'll find chapter 6 somewhere. I don't know why the fonts are all messed up, but yeah, it's all there. Well, come on, this book is 12 or 13 years old now, I think. 12. I mean, math doesn't change all that much. It really
That's
doesn't.
true.
Numbers are numbers. What changes a lot are some of the word problems, so they don't seem so out of date. Like we'll have ones come up talking about CD sales. When was the last time you guys bought a CD? Like a physical compact disc?
Something like.
I think I've ever bought one.
Yeah.
I don't know, it was, I
Hold on.
Do we even
26?
I was just gonna ask a simple question, but if you want to do the whole thing, that's alright too. Why not?
Find all the zeros. That's find all the zeros, right?
Yep.
I'm gonna walk through 26 here, guys. You remember how yesterday we had two people in the class that had the same birthday, and I told you guys had someone first hour had a birthday also. Did you know at the time that you get about 23 people in a room, you have almost a 50% chance that two people share a birthday?
Yeah.
It's you only have to have 23 people in a room to have a 50% chance of two people sharing a birthday.
Okay, anyone
So
got
wait,
You go
so
to
you
the
double
minute
it
you go
and
to 30 people in a room, you have just almost a 70% chance of two people sharing a birthday.
What about if you have like?
Alright. Anyone got March 3rd?
Let me do this first, and then we'll go through that, okay?
Like 46.
So this one here, I gotta check plus minus 1, 2, and 4.
Wait. Oh. Okay. I was just gonna find the. I don't even know. I just really
That's how this thing. Could you group in threes?
Nope.
Oh. Okay.
Grouping only works with 4 terms.
That's what I started to do, so that's why I messed up. I didn't.
I'm being told try -2. Hey, you guys want to know a really cool trick?
Yeah.
Let's say you're going through and you're allowed to use a calculator on the test, and you have a point where you're trying to figure out where in the world do you start. Yes, ma'am.
Bracket.
I would Yeah.
It does work.
The what I would do sometimes.
She grouped.
Was it x to the 5th? What's the next one?
Plus 2x to the 4th. Plus 3x to the 3rd. Plus 6x.
Ah. Plus 3x cubed. Plus
6x
You guys
squared.
weren't very helpful.
Plus 2x.
Hey, you got your phone fixed.
Yeah.
Plus 4.
Yeah, I was like,
4.
what are you doing?
So if you wanted to, get an idea of where to start, hey, I'm gonna start at -2 because it crossed the x-axis at -2. Woo!
Well,
Wow.
height.
Okay.
And that's it.
So now I have a term at x plus 2, and now I'm down to x to the 4th plus 3x squared plus 2. What times what's 2 you add together to get 3? And now you'll be able to get your imaginary roots out of that. So you have zeros at -2, plus minus I, and plus or minus I root 2.
Can you do 12?
Might as well.
You should ask. Which one?
Hopefully you'll do it.
I can't go GCF here.
Do you group it?
No, because if I take out the GCFs, it's not going to work. So then it's calculator. Okay.
So type it in our calculator.
I'll just take a calculator. Okay. Yeah, so GCF doesn't work, and that didn't work. It's not going. But what way are your tails going?
Up.
Up and away in my beautiful.
That reminds me of when I took my driver's test.
Oh, yeah.
And Mr. Cordes had to tell me it was up and away and let me redo it 3 times and he still passed me.
And they all come.
Thanks, Mr.
It was a distance change, so they would.
I like legitimately did it 3 times.
They never fall out.
Up and
They tried.
I watch that all the time.
Did you really?
Yeah, I'm all about the dance. I can cut a mean rug. Thanks.
Right. And like
Thanks.
I can do the Charles tip like real.
I don't make fun of you, but at least to your face.
I'm a good driver. It's just like I got really nervous and do it and I mess up everything. Even though
What do you guys say? How shots fired?
Shots fired.
What is it, you youngins? What is it?
Towards the curve.
She's so proud of herself. She thinks it's funny.
That was good.
What do you want?
Can you come here?
No. What else? Anybody else want?
No.
That's so rude. My birthday was yesterday.
Yes.
And I rolled my ankle.
Oh, she did. She got hurt yesterday.
I go to the